All right, number 6. Given the function f prime of x below, which of the following relative extrema will f of x have? Okay, so it's talking about relative extrema that could be maximums or minimums, and it's talking about f prime of x. So we're given the derivative. Now, what does the derivative tell us in relation to maximums and minimums? Okay, here's what we know. If something goes from increasing to decreasing, it's a max. If something goes from decreasing to increasing, it's a minimum. And in this particular case, how do we get that information from f prime? F prime, in order for it to be a minimum, which is each one of our answers, so it's just asking about basically where is there a minimum, we have to go from decreasing to increasing. So f prime is going to change from negative to positive, right? The slope is going to change from negative to positive. That's what we're looking for. So before we can find that, this is essentially the first derivative test again, where we start by actually setting this equal to 0. And we solve to find our critical points, which we're gonna put on our number line. So let's see, each one of these gets set equal to 0. Well, if negative x equals 0, that just means x equals 0. X minus 5 equals 0, well, that's just going to be x equals 5, and then finally x equals negative 3. Now, these aren't necessarily our answers. We can't just circle all of these yet. These are our critical values, where we're going to have horizontal tangents and potential max-mins. So this is where we once again have to go to our number line and actually see, okay, at negative 3, is it changing from negative to positive? Is it changing from positive to negative, or is it not changing? Maybe it's going from negative, leveling out to negative again. So this is where we have to once again plug in numbers on either side. So I'm just kind of writing down which numbers I'm choosing to plug in that will help me find the slopes in each case. So let's start by actually plugging in negative 4 into our derivative. So we already have our derivative here, so we can plug in a negative 4, negative 4 minus 5 to the third, and negative 4 plus 3 squared. And let's actually do the math here. This would turn into a positive 4. This would turn into a negative 9 to the third power, and this would turn into a negative 1 squared. Well, the beautiful thing about squaring something is that it's always going to be a positive, right? It's either going to be negative times negative or positive times positive. So that's going to be a positive. What do I know about multiplying 3 negatives? That's going to be a negative. We already did negative times a negative, so that's a positive there. So we have a positive, negative, and a positive. That means our entire interval is going to be negative. That means that f prime is going to be decreasing on that interval. Sorry, f prime is going to be negative. F is going to be decreasing on that interval. We have to do the similar work to find f prime of negative 1, this next interval, right? So just remember that just right now, we just know that it's decreasing all the way to the left of negative 3. We don't know what's happening to the right of negative 3. That's why we're plugging in negative 1. So we're going to plug in negative 1, negative 1 minus 5 to the third, and negative 1 plus 3 squared. Well, we already talked about if you square anything, it's going to be a positive. So this whole thing is going to be a positive. This is going to be a negative to the third power, which we already determined was a negative. And we have a negative of a negative here, which is a positive. So we have positive times a positive, which is a negative. So we went from negative to negative. Is that enough for that to be a minimum? No. So in fact, it can't be negative 3 because it has to change from negative to positive slopes in order for it to be a minimum. So I can cross off that answer right now. But we still have to do some work for 0 and 5. So let's see what happens to the right of 0, f prime of 1. And we're going to once again just plug that in to our derivative, which just comes from up here. We already determined that anything squared is a positive. This time we still have a negative to the third power, so that's going to be a negative. And now we have a negative of a positive, that's going to be a negative. So now we finally are multiplying 2 negatives to get a positive here. So now we do have a change. We have a slope that changes from negative to positive or from decreasing to increasing. So that tells me that at 0, we must have a minimum. So I can come up and I can check this one. But it did say choose all that apply, so I still have to check 5. But here's what I know about 5. I know it can't be a minimum because look at what's happening to the left of 5. So even though this went down to up, this is going up. The most it can do is maybe change to come back down, but that would only make it a maximum. The only way for 5 to be a minimum is if it was from a negative to a positive, if it went down to up. But it can't do that because from the left it is going up. And it can't go any other direction. So it can't be this. And you can check it. If that was a plus, that wouldn't do anything. If that was a minus, it still wouldn't be a negative at 5 or a minimum at 5. So our only answer was a relative minimum at x equals 0.